Okay, this is the second problem of the practice exam. In this problem, we have two curved plastic rods. It is on the XY plane, so that the one curved plastic rod is on the uh, positive side of the y-axis, and the other plastic rod, which is negatively charged, which is on the negative side of the y-axis. The amount of charge on each rod is the same, but their signs are different. So in the this one you have, in the top one you have plus charge, and in the bottom one you have negative charge, minus charge. So our task is to find the uh, electric field due to this charge distribution at the center of this circle, that is the origin of the coordinate system, observation point P. So we need to find the uh, electric field at this point. Okay, now this is the approach. I'm going to get the positive charge rod first, and I'm going to get the direction of the electric field. Then I'm going to get the negatively charged rod, and get the direction. Then uh, we'll go to the magnitudes. Okay, now I'm going to consider positively charged rod. The total charge on this rod is Q. Then the charge density, so we're going to define linear charge density, charge per unit length, lambda. Lambda equals total charge divided by length of this curved plastic rod. The radius is r, then the length, this length is complete circle is 2 pi r, that is the circumference of the circle. So this part, this section is only phi r. That is the charge density. This plus the charge density of this one, I'm going to call it lambda minus, that's equals to minus q, that is the charge, divided by phi r. So these are the charge densities. Now I'm going to consider small segment of this plastic rod. The length is ds, and the amount of charge on that small segment, let's call it dq. Dq is the amount of charge on that small segment. That dq equals lambda plus times ds, linear charge density, times the length of that small segment. So I'm going to select this small segment, so that this is so small, so you can treat that as a point charge. And we know how to write down the electric field due to point charge at any observation point. So this is my point charge, this is my point charge, and this is the observation point. And let's get the direction of the electric field. So if I draw this line, I can see the direction of the electric field is in this direction. That is the direction of the electric field, and this electric field is dE. The angle this small segment makes with the positive x-axis is theta. Similarly, I'm going to get another segment from this side, and the angle this small segment makes with the negative x-axis is also theta. The length of that segment is ds. Then it create a electric field in this direction, dE. The magnitude of these two electric fields are the same, y, the same amount of charge, same separation from the observation point. How do we write the electric field dE? dE is 1 over 4 pi epsilon naught, that is the electric constant, times the charge dq, divided by separation is r, r is a radius, r squared. The direction is direction, you can get that from the diagram. Now again I can write dE, which is 1 over 4 pi epsilon naught dq, which is lambda times ds divided by r square. That is the electric field. Now I'm going to consider x and y component of these two electric fields. The y components, they are along the negative y axis. These are the two y components. They add together to give the resultant y component along the negative x direction. X component, on the other hand, they acting along opposite directions. They cancel out to give resultant x component of these two electric fields to 0. So the resultant electric field is along the negative y direction. So what I have to do is I need to consider all the small segment. The length of each segment is ds from this end to this end to get the resultant electric field. So when you go from this end, from the positive x-axis to this end, to the negative x-axis, theta is changing from, theta is going from 0 to 180. Similarly, you can get two segments from the negatively charged rod, one here and one here, and since this is negatively charged, the direction of the electric field due to this small segment, this one, should be in this direction. The direction of the electric field due to this segment should be in this direction. Now again, their x components cancel out each other, y components add together to give the resultant electric field along the y direction. So now we can see from the symmetry the contribution to the electric field from the positively charged rod and the negatively charged rod is the same. So therefore, if we calculate the electric field created by the positively charged rod and then if we multiply it by 2, we will get the net electric field. dE equals 1 over 4 pi epsilon naught dq divided by r squared, and dq is dq equals lambda ds, and lambda equals, it's given here, lambda equals q divided by phi r. So I can write dq equals q divided by phi r times ds. Now the ds is the small segment, the elemental charge we consider on the charge rod. The arc length is ds, r is the radius, and the d theta, let's take d theta as the angle subtended by small segment ds. Then I can write ds equals r d theta. So from that I can write dq equals q divided by phi r, ds equals r d theta. So this boils down to q d theta divided by phi, that is the dq. So I can come back to this equation and I can write dE equals 1 over 4 pi epsilon naught d q, instead of dq I'm going to write q d theta divided by phi. This is what I have, times r squared. Now I want to get the y component of this dE. So dEy is dE, let's go back to this triangle, and you can see here this is dE, and this is the x component dex, and this is the y component, DEY, and this angle is theta, so this angle going to be theta. This is again the y component, the DEY, and DEY equals DE sine theta. I can write this is DE sine theta. Then DEY equals 1/4 phi epsilon naught Q sine theta times d theta divided by phi r square. Now I have this. I want to find the total electric field at point P. So if you consider the upper section of the of the upper rod, the positively charged rod, to the net charge from the positive rod equals this. So if I consider all the segment from starting from this point up to this point, all the way around like this, so what I have to do is I have to integrate this DEY starting from 0. The angle is changing from 0 to 180. So that will give the net or the contribution from the positive rod. The total contribution is 2 times E plus Y, the contribution from the positive rod and contribution from the negative rod, they are the same. So this is going to be the E net electric field at point P. So E net equals 2 times E plus equals 2 times integration of DEY from 0 to 180. So this is E net equals 2 times 0 to 180 DEY, which is 1/4 phi squared epsilon naught r squared Q sine theta d theta. So we have everything: Q sine theta d theta, 4 phi squared epsilon naught r squared. So this is what we have. Now you can see Q, 4 phi r squared epsilon naught, all these are constant. They are constant of this integral, so I can take this out from the integral and I can write E net equals, and here also you have 2, you have 4 here, that's going to be 1/2. So Q divided by 2 phi squared r squared epsilon naught integration of sine theta from 0 to 180 degrees. Integration of sine theta equals minus cosine theta plus c, an arbitrary constant. Then I can write this equals E net equals Q divided by 2 phi squared r squared epsilon naught. This is minus cosine theta, and limits are 0 and 180. Cosine 180 is, I'm going to take this minus sign out. Cosine 180 is minus 1, minus cosine 0 is 1. So I'm end up with minus minus plus 2q divided by 2 phi squared r squared epsilon naught. That is q divided by phi squared r squared epsilon.